Here we go. 1C.11 equivalent representations, part 2. Remember, I am taking a little more time on this because I know that in Algebra 2, we had a little lapse in time and we rushed. So I'm intentionally making sure that we have this strong foundation because it's a prereq that you should have had. And as your teacher, I know you don't. So, here we go. Things that we're going to do. Anytime that you are analyzing rational functions, this is where you should start. First, you're going to always take your rational function and you're going to put your numerator and denominator in the lowest terms, which means you're going to factor it, right? Do we all feel confident in our abilities to factor right now? For the most part, as we practice, okay? Next, we should be able to identify your domain. Your domain depends on your vertical asymptotes and your holes. So when we're looking for our domains, we're identifying our VAs and our holes, okay? When you're identifying your VAs and your holes, that's telling you your discontinuity along your domain. Where am I going to have to stop and restart, recontinue my graph, okay? Next, you're going to determine your intercepts, if any, of the graph. Remember, your x-intercepts come from your numerator equaling 0, and your y-intercept is just going to be if I plug in 0 for all of my variables, what am I left with, right? Okay. You're going to find any real zeros of your denominator. Those real zeros are going to be your vertical asymptotes. Then we're going to locate any horizontal or oblique asymptotes by paying attention to our degrees of our numerator and denominator. Okay, next we're going to decide if there's symmetry. So when we talked about symmetry before, we only looked at it from a polynomial, not a rational perspective. Same rules apply. When you're determining if it's symmetrical or not, you are still paying attention to whether, if I have negative x and r of x, if they're equal. So if I have r of negative x, if it equals r of x, then that means I have even symmetry, right? If I have r of negative x and negative r of x in their symmetry, then they're going to be odd, which is your origin symmetry. So remembering that we have, when it's y-axis symmetry, that means that it is even symmetry. When it's origin symmetry, that means we have odd symmetry. Okay, then we're going to decide whether the graph lies above or below our x-axis, our zeros, and we're going to graph our asymptotes. So at this point, we should be able to do all of these things. We've been doing them piece by piece, and now it's going boom, all in one. Okay, that's what this part is about. So let's dive into one big problem. All right, so here we have r of x equals x squared minus x minus 20 divided by x cubed plus x squared minus 12x, okay? And we want to first start off with being able to write it in factored form. So writing this in factored form should be fairly quickly done and comfortably done. You're going to always generally have simple polynomials after you've taken out the GCF. Does that make sense? So it may not look simple at first, but once you realize that there's a GCF, once you remove the GCF, the problem should be pretty straightforward. So in this situation, there's no GCF in our denominator, but in our numerator, but there is a GCF in our denominator, correct? So we're going to go ahead and factor. So we're factoring r of x, which equals, and your numerator, what multiplies to give me negative 20, but adds to give me negative 1. What? 5 and 4. What kind of 5 and 4? I need a negative 5 and a positive 4. In my denominator, I have a GCF. I take that out. Now I ask myself what multiplies to give me negative 12, but adds to give me a positive 1. Okay, that is my factored form. Then we're going to reduce it. And when I reduce, I'm left with x minus 5 over x times x minus 3. Agreed? Okay, now you're going to find your zeros. Your zeros are going to come from your reduced form. So what was left in my reduced form in my numerator? So I'm left with x minus 5, and I'm going to set that equal to 0. So then my x-intercept is at what? So we have an x-intercept at 5, 0. Okay, next is finding the value of your hole. Your hole comes from what did you reduce? It's going to be, I reduce x plus 4. If I set that to be equal to 0, that means I have a hole at x equals -4. Where's that hole exactly located? To find where the hole is exactly located, that means you're taking this value and you're plugging it into your reduced form. So if I have x equals -4 and I plug it into my reduced form, that's how you're going to find the y of it. Does that make sense? So the x is at -4. To find the y, I'm substituting -4 in. -4 minus 5 is -9. In the denominator, I have -4 minus 3, which is -7 times -4 is 28, right? So therefore, my whole would be at -4, comma, -9 over 28. A really tiny number, right? Okay. Now our vertical asymptote. Your vertical asymptote, again, going back to your reduced form. What was left in your denominator and your reduced form? We were left not with just 3, but what else? X. We were left with x, which is x equals 0. And we were left with x minus 3, which means that it would be at +3. Okay. Do I have a horizontal asymptote? Go back to your degrees. Yes, where's it at? At y equals 0. It's at y equals 0 because the degree of the numerator is less than the degree of the denominator. So we have a horizontal asymptote at y equals 0. Okay. To state your domain depends on your horizontal asymptote. No, I'm sorry, your vertical asymptotes and your poles. So when I'm looking for my domain, I'm going to identify those values. So my domain depends on my vertical asymptote, which is at 0, 3, and at my hole. And my hole is at -4. Okay. When you're writing out your domain, you're putting those values of discontinuity in numerical order. Okay. Rational functions start from left to right. Start at the left. So all the way at the left, I'm at -infinity. I'm traveling along, and which one of these discontinuities do I hit first? -4. So that's where I have to stop. Then I restart. I'm traveling. Which discontinuity do I hit next? 0. Then I stop. And I keep going. 0 is going to end up hitting 3. And I stop. And 3 continues on to infinity. Okay. That's how your domain is determined based on what are the discontinuities of your x. Make sense? Okay. All right. Next part is sketching it all out. So sketching it all out at this point, you should be able to put all your pieces together. So we know that we have a 0, right? At 5. So at 5, it should be a closed circle, which is interesting because what's unique about my x-axis, it has a horizontal asymptote at y equals 0. Remember we talked about those special cases where horizontal is not as strict as your vertical? This is an example when you have that x-intercept. Okay. Next, we're going to draw in our asymptotes. We have them at 0. I feel like I should do it with a highlighter because you can't see it. See if that'll help you see my 0. There's an asymptote there, and I have an asymptote at 3. Okay. And you have your hole is at -4, -9. So I know that at -4, -9, There's a little tiny hole in this little guy somewhere. What makes this hole significant is it just lets me also know what direction my graph should be, right? Because the hole is below the x-axis, that lets me know that my graph is also below the x-axis. This is not a closed circle, it's a hole. I just can't make it really big because it's at negative 9/28. I can be obnoxious, I guess, but just trust it that's at approximately negative 9/28. Trust the process, okay? The other thing that we do know is that now we have to figure out which way is our graph going all the other times. So when it says sketch your graph, do you guys remember when we had to decide whether something was positive or negative, right? Above or below? It's the same thing here. So you have to decide, is the sketch above or below the x-axis? And you just do that by choosing a value and plugging it in. And you plug it into the reduced form. So for example, if I chose 1, so let's say I want to know at 1, is it above or below the x-axis? All I'm trying to do is figure out what is the value of 1, right? I'm taking 1 and I'm plugging into this reduced form. Does that make sense? I'm taking the value of 1 and plugging x equals 1 and plugging it in here. So when I take 1 and I plug it in, that gives me 1 minus 5, which is negative 4. And then I have 1 minus 3, which is another negative 1, negative 4. And negative 4 divided by negative 4 is a positive 1. So I know that this value has to be above. So at 1, it's doing this. And all I need to know is that, because then I can sketch out the rest in between the asymptotes. Okay? And again, you would do the same. Choose a value in this space. So we know that R of 1 equaled 1. Choose another value. R of, forgot that's the no writing zone. R of 4. Evaluate that. I plug in 4. 4 is going to give me 4 minus 5 over 4 times 4 minus 3. That gives me negative 1 over a positive something. 4. So I know here it has to be going like this. Does that make sense? Because this has to be down here, which means that I have to be going. I didn't mean to go. There we go. That high, but. And we continue. And that would be your sketch. That's all things rationals put together.